Hi everyone, welcome to my channel. In my channel, I have already discussed about periodic table. Quite a good classification with it. However, today I will discuss about the history of periodic table, from where it started, how were the elements first discovered and what changes were made later on. So, let's start with this. Now, in order to put things together in a group toward the end of 18th and 19th century, more elements were discovered. More elements were discovered to make their comparative study easier. First, Daubernier was the one who started this concept. According to his way of arrangement, the atomic mass of the middle element of a triad was approximately equal to the average of the atomic mass of other two elements of the triad. Okay, triad means considering three elements at a time. Now, their atomic mass was considered 40, 88, 137. It was found if I take the average of calcium and barium, then the mean was equal to 88.5, which is almost equal to strontium, which is placed in the middle of the periodic table. And this is how he started grouping three elements at a time. This was done, and this was going also with some elements. However, he failed to arrange all the known elements in form of triads. This means not more elements could be discovered in this way or could be arranged in this way. The known elements which were very well found in the environment or in the atmosphere, they couldn't be arranged in this manner. Next, the law did not fully apply even within the same family. If we are grouping one element or a group of elements in a particular table, in a particular family, they could not be arranged in this manner, which basically means that this is the not right manner of arrangement of elements. And hence, this needs to be changed or modified further. Next came Newland law of octave. Octave means basically 8. In a musical note, if you have got 8 musical notes, then it is known as octave. So, this was discovered by Newland. According to him, the properties of the 8th element, like if you are arranging atomic mass of element, then the property of the 8th element starting from any element are a repetition of the properties of the starting element. 8th element means if I arrange like 1, 2, 3, 4, 5, 6, 7, 8, then 8th element and first element is going to have similar property. This also had a drawback. Classification could not work for the heavier element, When more and more elements were discovered, they could not be arranged or they could not be fit into the Newland octave format. Some having similar property were placed quite far from these elements. Like first element, 8th element, they are not having similar property, but the 11th element is having. So this law is no more applicable. Again, this got modified by Mendeleev, who said that physical and chemical properties of elements are periodic function of the atomic masses. So, if I take any element and describe their atomic mass, like for hydrogen it is 1, for helium it is 4, for lithium it will be 7. So, he is saying that the chemical property and physical property of the elements are going to be periodic function of their atomic masses. Means mass is the one that is responsible for their periodicity. Okay, this was considered, and he only said that why the name is periodic table, or why is the arrangement known as periodic table. So it is basically a chart of element where the elements with similar properties are going to occur in the same column. It is known as periodic because the elements with similar properties occur at fixed interval, and this arrangement in the tabular form is known as periodic table. Periodic means after certain interval the same property is being repeated or it is following a particular method. So this is why it is known as periodic. Okay, periods and groups. Now what exactly will be there in the periodic table? Certain periods and certain groups. So these arrangement is known as periods. Horizontal rows, where 7 horizontal row is known as period, and vertical columns were 18. These are 18 in number. Like this, we are having 18 groups. Okay. Merits of the Mendeleev table. Mendeleev was very much close to the current or modern periodic table, but there was some drawback. However, his merit was grouping of elements were correct. Gaps for undiscovered elements. Many places were kept for new elements to be discovered later on. Prediction of property of the undiscovered elements. Since his arrangement was based on physical and chemical property of the atomic masses, he can predict the next element may have what property or what will be its mass and something. And incorrect atomic mass was corrected. Some atomic mass was said different earlier, but he corrected it. And this is how his periodic table got some recognition, although there were some defects as well. An anomalous pairing of elements. Some element did not have match. They were anomalous. Position of the isotopes. Isotopes, those who know, I already have got a video in my channel. And also I'm telling in short, hydrogen H1, 2,1, H3,1. Elements which are having similar atomic number but different atomic masses are known as isotopes. Hydrogen have got only one position in the periodic table, but the other isotopes are having no position. So position of isotopes could not be fixed. Grouping of chemically dissimilar elements. Although he grouped the elements with similar properties together, there were some whose properties did not match. So chemically dissimilar elements were present. Separation of chemically similar elements. Some elements which are having similar properties were placed quite further. So that is not correct. Electronic arrangement. Now what does this mean? Position of hydrogen. Position of hydrogen is easiest, and this is already a problem now also in the current periodic table. So this problem and position of isotope, this is now also, it's still there. Electronic arrangement, this means it could not explain the electronic arrangement of the elements. See, he discovered atomic mass. Atomic mass could not describe your electronic arrangement. We know the number of electron is equal to number of proton, and that is equal to what? Atomic number, but not atomic mass. He discovered atomic mass, right? So he cannot tell what will be the electronic arrangement or how it can describe the electronic arrangement. So this was not at all in parity with his way of arrangement. So this is the greatest drawback. And finally, our modern day periodic law, which states that physical and chemical properties of elements are periodic functions of their atomic number. See, atomic number is basically a serial number. We have got, like in school, you students will be having a particular way of arrangement, like maybe A alphabet is coming at the beginning, then it will be B, then C, or the toppers are having roll number at the beginning, and so on. This serial number and roll number is similar to your atomic number. This is same as atomic number. So hydrogen got the first position. Hydrogen 1. Then it is helium. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, then it will be chlorine, argon, potassium, calcium. Okay. Yes, oxide, phosphorus. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have missed something in between. Sulfur. It will be sulfur 16, 17, 18, 19, 20. Till 1 to 20, please learn. These atomic numbers are very important, and their arrangement is also important till class 10. Class 10 students should know these atomic numbers and the correct way, like after hydrogen, helium comes in. If you learn in the periodic manner, 1, 2, 3, 4, this is the way. Also you can learn from top to bottom, like first it will be hydrogen, then it is lithium, sodium, potassium, rubidium, cesium. Like this also you can learn. Whatever be it, 1 to 20 should be known because it is important. Okay, this is the history of periodic table, and this is how the classification was done. And the second part I have already discussed in my channel. You can go and check the video. However, this part is also important. It is important to know from where it started. So I'll end it over here. That is it for this video. Thanks for watching.